Good morning children. We continue exercise 7.3 problems based on factor theorem. Question number 3, solve. A determinant is given with RHS 0. When the RHS will become 0 if any two rows or columns are identical. So I can very well use factor theorem to prove the problem. As I look out, if I add the columns, I get x plus a plus b plus c. Here also x plus a plus b plus c. Here also x plus a plus b plus c. If I put x plus a plus b plus c 0, I get x is equal to minus a minus b minus c. This is a clue that gives us when the question is solved. In the previous class, we were given RHS. So we try to achieve easily. Now, we are given solve. So we need to guess the roots or factors. So check in which way I can take any term out as common by adding or subtracting. Here by adding C1, C2, C3, I get x plus a plus b plus c as common out. So that would be the factor. If x plus a plus b plus c is a factor, I will get x is equal to minus a minus b minus c. Substitute wherever x comes. Minus a minus b minus c in determinant a. I get minus a minus b minus c plus a. B as it is, c as it is. Second row, a as it is in the place of x. Minus a minus b minus c plus b. C. A as it is, b as it is in the place of x. Minus a minus b minus c plus c. As we simplify, I get a cancels. Minus b minus c, a. Second column, it is b. B and b cancels. I get minus a minus c, b. Third column, c. C cancels minus a minus b. Now, to bring about two columns to be identical or two rows to be identical because the RHS is 0, check in what way I can do. Let me add column 1 and column 2. So, new column 1 is column 1 plus column 2. See what I get? Determinant A equals, as we are adding plus c minus c cancels, it is minus b. A plus c. A minus a cancels, I am left with minus b. Second column, b minus a minus c, b. C minus a minus b. As I look out, column 1 and column 2 are identical. Or I can say they are proportional. Minus symbol alone is different, otherwise they are same. Such models I say C1 proportional to C2. As we know in the previous class, we took the minus sign out and we showed identical. Or I can directly say they are proportional and therefore the determinant value vanishes. When the determinant is 0, I can conclude x is equal to minus a minus b minus c is a root of determinant A. The next idea, check in other way I can guess the root. In the given problem, if I remove x, a, b, c. So again we get easily the proportional idea. So wherever x is coming, let us put 0. So if I put x 0 in the determinant, I get A, B, C. As I check, 3 rows are identical. I can easily say R1 identical to R2 identical to R3. Therefore, x is equal to 0 is a root with multiplicity 2. Why do I say? Whenever 2 rows or 2 columns are identical like the previous case, we say it is a factor or it is a root of the equation one time. But if 3 rows are identical I will immediately declare it is a root 2 times, twice. So x is equal to 0 is a root twice. Already I achieved minus of a plus b plus c as a root. How many roots have we got? 3. What is the degree of the determinant? X. Diagonally I multiply, it is x cube. So degree of the determinant is 3 and we have achieved the 3 roots and the problem is done. Question number 5, solve. Given a determinant equals to 0. Again, I can use factor theorem. In what way? As I look at the determinant in the LHS, x has come everywhere with plus symbol or minus symbol. The remaining numbers are same. So put x is equal to 0 in the determinant A. Check what comes. 4, 4, 4. First column. Second column also 4. Third column also 4. What changes is plus x or minus x. So we have put x is equal to 0 and we got 3 columns to be identical. Whenever 3 columns are identical, we declare x is equal to 0 is a root twice, or I can say x is equal to 0 is a root of the equation determinant A equal to 0 with multiplicity 2. What is the degree of the determinant? X. As I multiply x into x into x, x cube will come. So the degree of the determinant is 3. I must arrive at 3 roots. Here I got 2 roots, 0 again 0 because the multiplicity is 2. Now I need to find out the third root. Check whether by adding or subtracting I can bring anything as common. As we know, 4, 4, 4. I add, I get 12 in every column. But plus x minus x cancels, I am left with x. Plus x minus x cancels, I am left with x. Plus x minus x cancels, I am left with x. So by adding C1, C2 and C3, I get 12 plus x everywhere in first column. So I can take 12 plus x out. That tells me x is equal to minus 12. As I substitute x is equal to minus 12 in determinant A and simplify, I am not getting any columns or rows identical. Let me try to bring it. Just add C1 and C2. So what we are doing? New column 1 is column 1 plus column 2. 16 minus 8. Minus 8 plus 16, minus 8 minus 8. Copy column 2 and column 3 as it is. Take minus sign out of column 1. I get minus 8 plus 16. Second column minus 8 plus 16 minus 8. Third column minus 8, 16. And now column 1 identical to column 3 and so the answer 0 is verified. Therefore, x is equal to minus 12 is another root. How many roots we have shown? 0, 0, minus 12 and the problem is done.